So what we have here is a 35mm spectralizer that is connected to ConCube. And I'm going to use this system to demonstrate a few features of Anatool. In Anatool we have two different kinds of alarm algorithms for event detection. We have the spectral alarm that is made to make use of spectral fingerprints, and we have the pattern alarm that is made to detect deviations in the relation of measured parameters. So I installed this system now about 2 hours ago. I have here a bucket with normal tap water, which we are measuring right here now. Maybe the first thing we can do is have a look at the time series we recorded so far. So what we see is just typical values for drinking water, and we can also have a look at the fingerprint of the current measurement, which we see here. So this is also typically drinking water. Okay, so I will start now by creating two different alarm parameters, one spectral alarm parameter and one pattern alarm parameter. This is done, and we click on the Anatool icon, where we have the possibility to create a new alarm parameter. I will start first with a spectral alarm. I enter a name, click on create, and in the next step we have to select the fingerprint for the spectral alarm and all available wavelengths. Clicking on save, we are finishing the process. Now the new alarm parameter is created and automatically trained. Next I will create a second Anatool parameter based on the pattern alarm algorithm. I also have to select the name and the inputs. The pattern alarm parameter is made to handle mainly simple parameters such as turbidity, nitrate TOC. I'm selecting the parameter and I'm selecting either the directly measured raw value or the clean value that went through the data validation process in Anatool. Normally we recommend using the clean value, but for this demonstration here I have to select directly the raw value, the measured value, because otherwise Anatool would remove our very short-term simulated contaminations as outliers. So I will just select a few of the available parameters, and I finish the creation of the new parameter by clicking on save. We can go back to the values tab, and here we see that the new alarm parameters are already visible here. Measurements are still stopped because we went into the service mode. I will now click here to go out of the service mode and continue the measurements. We can now see that the new Anatool alarm algorithms started to work. They have collected the first input measurements, and we see the first results of the new parameters. We will now continue by testing the behavior of the alarm parameters to simulated contaminations. We have a few substances here. This is coffee, orange juice, and cranberry juice. And we can use these substances to test the sensitivity of the two event detection algorithms. I'm going to start with a contamination of 1 drop of coffee. So what we can see here is the first event that was detected by both of the algorithms. We see a very strong reaction of the pattern alarm and of the spectral alarm. And I will now replace the water in the reference slide in order to end the contamination alarm. It is necessary to really flush the reference slide very well, at least 3 or 4 times, in order to make sure that the water is clean again. So with the new fresh water in the reference slide, the contamination ended, and both alarm values go back to normal, and the events in Anatool, the event in Anatool stopped. We can maybe now have a look at the fingerprint and the parameters to check the event and analyze what was happening here. First step is to have a look at the time series. We can see that most of the parameter values were changing relatively strong due to the coffee in the reference slide. We can also see how this is visible in the fingerprint. If we now compare the fingerprint that was currently measured in pure drinking water and compare this fingerprint to a second one that was recorded earlier during the contamination with coffee, we can very well see that the difference between those fingerprints plotted in blue corresponds to the absorption spectrum of the coffee in the water. What we can also see is that the alarm icon on the alarm tab is flashing. This is to notify the user that there is a current alarm pending. We have 2 alarms in this table, 1 alarm from the pattern alarm and 1 alarm from the spectral alarm. We can click on the alarm and give a feedback to this alarm. So the feedback is either to reject the alarm as a false alarm or to confirm it as a true alarm. We can also select 2 alarms at once and, for example, in this case, confirm both at once. We add a remark, so we say this was coffee. Click on save, and we have now cleared both alarms. We still have warnings here, which we can clear by clicking on clear all warnings. So currently we have no more pending alarms, and the alarm icon on the alarm tab stopped flashing. So as a next step, I'm going to test the reaction to one of the other substances. I will use the orange juice now, put the drop in, have to stir a bit. So also the orange juice is detected by both algorithms. The reaction is slightly weaker than was the reaction to the coffee, but still it is clearly visible and easily detected by both algorithms. I will now show a second way how to go into the analysis of an event. we can click on the alarm history here, and we get a time series of all events that happened on our system. If we zoom in, we can see that we have had one event here in the during the contamination with the coffee, and we have a second event that is still going on, and which is due to the contamination with the orange juice. Clicking on the bar, we can also add a comment here. Okay, this was a true alarm by clicking on confirm, and I will also do this with the second event here. I will now go out of service mode, continue the measurements, and in the meantime change the water. And what we see right now is that changing the water to fresh tap water brings back the system to a normal state. Our final contaminant is cranberry juice. Going to add some to the tap water. And after the next measurement, we have our full collection of data from 3 different contaminations in the tap water, and we can start to play with different configurations. So that means by modifying our feedback to the different events we see in the data, we can modify the behavior of the different algorithms. So that means, do we want to see a reaction of the alarm algorithm to a certain substance or not? So again, also now for the cranberry juice, we see an alarm that is comparable to the alarm we have had due to the orange juice. I will now go to the alarm tab and into the alarm history to provide feedback to the current alarms. I will now, in the first step, confirm the alarms. So what we are going to test now is to train the alarm algorithms to react on one of the juices and not on the other one. So we are going to classify one of the juice events, for example the orange, as a false alarm, and then retrain the alarm algorithms. What we expect is to see that a contamination with orange juice then does not trigger a new alarm, but that the contamination with coffee and cranberry juice is going to trigger an alarm. So the first step is to go back to the alarm tab and enter the alarm history view. Here we can now use the alarm history view to manage our previous events in the system. If I select the orange event of the pattern alarm, I can now click on reject to reject the event. I will do the same thing for the orange event of the spectral alarm. And in order to make these changes take an effect, we have now to manually trigger a training. I will start with a contamination with coffee. In this case, I expect to get an alarm because we did confirm the coffee event and we did only reject the orange event. So coffee should still trigger an alarm. The coffee, as expected, triggered an alarm, and before the next measurement is done, I will replace the water in the reference slide in order to stop the alarm. The next substance we are going to test is the orange juice. As before, we rejected the event caused by the orange juice. The expectation is that this time the orange juice is not going to cause an alarm in the event detection system. As before, we classified this event with our feedback as a false alarm. That means that we do not want to see a reaction. So what we can see here now is that we already have the results of the new measurement with the orange juice in the reference slide, but both of the alarm algorithms did not trigger an event, which means that the training successfully adapted the behavior of both alarm algorithms. The final test that stays now for our system is to check whether the alarm algorithms are going to detect a contamination with the cranberry juice. I'm pretty sure we're going to see an alarm of the spectral alarm algorithm. The pattern alarm algorithm is going to have a hard time to distinguish the substances, but we are going to see if it's going to be possible. So we can see that both of the alarm algorithms were able to successfully detect the contamination with the cranberry juice, which means that they were able to distinguish between the relatively similar signals of orange juice and cranberry juice.